Okay. If I plug in a number, do I get a square root? Do I get a whole number? What kind of number do I get? If I plug a value in for x. Fraction, right? Is that cool? I get a fraction. What cannot happen in a fraction? What can I not let happen? Zero where? The where? If the top of a fraction is zero, it's bad.
Zero.
Yeah. No, yeah, it's zero. If the bottom of a fraction is zero, that's where things get weird. You can't divide by zero. Okay, so whenever I give you any function and I ask you what's the domain of this function, you just say to yourself, what can I not let happen? So for example, real quick, just to kind of go on this general idea of domain. Oh, that's right. I've got everything in the universe in here. Okay. Are you? Yes. Okay. Real quick, what if I gave you this function here? Square root of x plus 2. And I'm thinking about graphing this thing, so we're going to stay with real stuff. What can I not allow? What must be true for this to come out real? So when I ask you what's the domain of this, I always inherently mean real numbers. Yeah, it's got to be positive. What's the smallest it could be? What's the smallest number? Oh, okay, so you're thinking about x. What's the smallest number and put inside of a square root is 0, correct? So if I say in English what I need to happen, the inside, what must be true about the inside of a radical? It's got to be at least 0. Is that cool? Just that's what's got to happen to keep stuff real. The inside's got to be at least 0, correct? So whenever I ask you, I give you a function and I say, what's the domain of this function? If you could just say in English what you wish would happen, what you need to have happen, translate that to mathish. Inside, well, what's the inside in this case? What's the inside of the function? X plus 2. At least. What is that in mathish? No, at least. What symbol is that? Greater than or equal to.
Oh, okay.
All right. I know you're thinking about interval. Okay. Inside is x plus 2. At least, greater than or equal to 0. And then you solve that, and that's the domain. It's almost too silly to believe. I ask you what's the domain of this function. If you can say in English either what needs to happen or what can't happen. So if I give you, so then you get this. X has got to be at least negative 2. And sure enough, if you try to put negative 3 in, what kind of number am I going to get? If I try to plug it in negative 3, worse than that, imaginary, right? I'm going to get negative inside of a radical, which means it would lead to imaginary. Are you guys with me? So whenever you get a question in this class, and it says find the domain, they inherently mean using real numbers, right? We know complex numbers exist, but in this class, we are only graphing real stuff. Thankfully. Actually, it's kind of neat, but thankfully for all of us, we're only doing that. Okay. So real quick, what if the function was this? And this is getting to the point here. Can you say in English what can't happen? So bottom can't be 0. Do you guys agree? Anytime you see some fractional looking thing, the bottom can't be 0, right? You can immediately just say that. Now write it in mathish. What is the bottom? What is the bottom? X squared minus 4. Can't be. What do you guys think can't be? Equal with a not. Not equal to 0. And then you solve that. So you could add 4 over. You just got to remember, when you take a square root, what do you have to put? So then I can't let x be plus or minus 2. And it makes sense. If you try to put a 2 in there, you get a 0 on the bottom. It'll freak out, right? You guys see that? You guys see that? Anytime anybody gives you a function and says, what's the domain? Just say in English. It's kind of nice. You can just start with English. What can't happen, or what do I have to have happen? And then you write what you just said in Mathish and solve it. It's crazy. Okay, I like it. So does that help with that problem? So what do you have to do with that problem back here? Number 9. What do you have to do with that? Oh, yeah. Okay. Yeah, you got to factor the bottom out. I love it. Okay. So maybe talk to me after. Okay. Is that okay? And real quick, is anybody freaked out about the bottom of that fraction? Yes. Okay. Okay. So it was. So let me give you one like that, so I don't do all the homework for you. What do you got, Jeff? Sure. So let's say I've got this. So I got to figure out, when is this? What's this guy's domain? It's supposed to just trying to be a 1. So I can't let the bottom be 0. So in order to figure out what makes it 0, I've got to actually factor the bottom, right? Now, real quick, if I had this, how would you factor this? See how all I did was I decreased the degree, right? How would you factor this? Yeah, XX, right? Split this in half, XX, and then you need the 2 numbers that make it work. Is that cool? You guys with me? So far, so good? So, how do I factor this then? X squared, and then it's still the same question. What 2 numbers work? Minus 4 plus 2. And do you see how this would be complex numbers, so I can ignore it? Do you guys see that? And this one I can actually factor further. I get 2 answers. 2 things that aren't in the domain. Do you guys see that? So you do exactly the same thing with the problem they gave you. You can factor any trinomial where the middle degree is half the first degree. Because what's the first thing we do? Split this guy in half, correct? And where does the middle term come from? This. Therefore, if the middle term has half the power this does, that might work. Yes?
I don't know if this is like relevant, but would the same process apply to if it was cubed? Because I remember on a couple quizzes or something, it was like x to the 9th to like plus 27 or something.
Okay.
You do the same thing where you'd be able to like split it into like.
Yeah. I mean, in general, yeah. So yeah, sure. If I had x to the 9th minus 27, your question to yourself is, so this is the same idea, but it's a little different, because if I see 2 terms, it could either be squares or cubes, correct? Can you cut everything in half? Nope. Can you cut everything in thirds? Yep. In which case, it almost doesn't matter if this is not a 3. All that matters is, can you cut it in thirds, right? I really want this to make sense. Well, I can always say that. So cut this in thirds, what do you get? If you cut x to the 9th in thirds, what do you get? x3, x3, x3. Is that cool? And of course, 27 is 3 times 3 times 3. So what goes in the little dude? 1x3 minus 1, 3. Right? Everything's the same. It's all the same. So squares and cubes will always work exactly the same. I'm sorry, man. Dude, can you... I'm sorry, man. Yeah, thanks, man. if it's squares or cubes, the process will always be exactly the same.
And if we did this, you wouldn't want us to like further keep going because then there's an x3 there. You wouldn't want us to be like.
It's very possible. Like if I would have made this, let me see if I can change this on the fly. If I would have made that a 1, this would have been 1, 1, 1, right? This would have been a 1. Could you factor this?
Yeah.
Totally. It's another cubes, right? Yeah, so then it becomes its own problem with little dude, big dude, right? This thing is never factorable, ever. Unless there's a GCF I left in. You can never factor the big guy. Do you remember I told you that big guy will always lead to complex intercepts? Which should tell you right there, you can't factor that like normal, right?
So you can't use the quadratic formula if it's like the degree is 3 or not 2?
You can only use quadratic formula if it's quadratic in form. This is quadratic in form because the middle power is half the first power.
Okay.
And if the first one's the cube, you would need the middle power to be a 1.5 power, which is already freaky, right? Yes?
So you know at the bottom how you had x to the 9 minus 1, and that was like the cubes?
Yeah, let me do this a little bit again here. So it'll be x cubed minus 1. Yeah, because this is x cubed, x cubed, x cubed. This is 1, 1, 1. I like it.
And if it was x squared minus 1, could you do the squares?
Of course, yeah. So, in fact, all right, since we're kind of here, there are things where you could do cubes or squares. So, for example, x to the 6 minus 1. Can you cut both of those in half multiplicatively? Yes, you can. What times itself is 1? 1. And what times itself is x to the 6? Cut that in half.
X to the 3?
X cubed, correct? You guys with me? Can you cut them both in thirds?
Yeah.
Yes! This would be x squared, x squared, x squared. This would be 1, 1, 1, correct? So you could do cubes or squares. In general, if you have a problem that you could do either cubes or squares, you do the squares first. And I'll show you why real quick. If I do the squares first, cut everything in half, what do you get?
X.
X squared?
Cut it in half,
Oh, X cubed.
x cubed. And of course, then you're going to get
A negative 1.
minus 1.
No, plus 1.
And what are both of these? What are both of these?
Factors.
No. I mean, can I go further?
You can go further on the.
Because what
negative
form are they in? No, I can go further on both. What form are they in? Are they squares or cubes? Cubes. Okay, so I could go further on both. They're both cubes. Do you guys see that?
Oh, you mean like X
All right.
outside and then X squared something on the inside?
No. Little dude, big dude. Little dude, big dude. Right? All right, you guys are looking at me like I'm crazy. So, why can I not factor x squared plus 9? Why can I not do that with real numbers?
Because you would get middle stuff.
You get middle
Because
stuff.
You can't do a negative and, or you can't, like, if you do a positive and a positive, there'll be middle stuff. And if you do a negative and negative, you can't do that when it's squared.
There'll be middle stuff. Exactly. Kick ass. Now, we have done both sum and difference of cubes. This is not news. Why does it make sense that things involving squares would have more issues than things involving cubes? What are we actually doing when we do x squared minus 9? Aren't we taking square roots? Right? So anything that involves square roots or even roots are going to be more uptight. They can't handle it when things are a certain way. Cubes they don't care. They could work either way. So again, if I try to solve both of these, which one is going to make things weird?
The top one.
Top one. So that's why I would expect the top one to be weird when I try to factor it, right? If I try to solve either one of these, I add one or subtract one, take a cube root, there's no problem. Cube roots can handle negatives. Do you guys see that? That's why I could do a sum or a difference of cubes, but I cannot do a sum difference of squares without bringing in freaking complex numbers, correct?
Because it's an even exponent.
Because in order for the middle term to cancel, I have to let both signs be different. And if both signs are different, they're going to make a negative. Does that make sense? The only way I can have a middle term cancel is if I have the last terms different signs. And if I multiply two things with different signs, they come out to be negative, unless they are imaginary, right? Yes?
So, can you use the quadratic formula for x squared plus 9?
You totally could, but I'm not sure why you would want to.
Oh no, I was just asking because you said like it has to be like half of like the 2 on the other column.
Yeah, what's A? 1. What's B? 0. What's C? So, totally will work, right? In fact, so just to make sure you understand, the middle term would be x squared plus 0, x plus 9. Is the power half the first one? Yeah, I just don't have any of them. Okay, I like it. I like it. So what could I use quadratic formula for? Could I use quadratic formula for this? Yes, beautiful. Why? Middle term is half the first term. I like it. So if somebody gave me this shit here, can't use quadratic, I'm going to start using instead synthetic. So when I can't use factoring directly and I can't use quadratic formula, synthetic comes into play. Okay, I like it. So synthetic is just another tool we developed to help us with this shit that's even weirder than the stuff we had before. And why do we keep doing that, by the way? I don't know from your perspective what this is like. Every time I introduce a new tool, in case the equation is weirder and weirder, we're getting closer to real life. Because in real life, if I set up an equation that models the weather, do you think it's going to be nice? Do you think it's going to have x plus 2 and x minus? No, it's going to be weird as shit. It's going to have some funky ass answers. We're going to have more complicated ways to solve it because it's more complicated. Does that make sense? So every time we do this, we're just not arbitrarily making things harder. We're saying, okay, let's get closer and closer to what we have in real life, right? Okay. All right. Anything else from homework? Yes.
I'm still like, I got stuck. I'm still stuck on 84. I have
84, where we are?
5.6.
Oh shit, I was there. All right, let's all look at 84.
So I subtracted it over, but then I got this and
Wait, let me catch up. So here you got this, then you plugged it in. And this one, all it says is use a calculator to answer the question. So that's the part, right? Use a calculator to answer the question. So what you're going to do is you're going to graph what you end up with, and you're going to find the intercepts in the calculator.
Okay.
Because they've given us, we end up with an equation we can't solve by hand.
So I'm at the point where I can't solve it by hand.
So you're going to plug that in the calculator, you're going to find the intercepts.
Okay.
Yep. Okay. So on number 84, notice it says construct a rational function that will help solve the problem. But then you're allowed to just plug it in the calculator. You're trying to find intercepts at that point. Okay. And if you haven't tried 84 yet, try it out. But if you have and you have a question, feel free. I've got a little bit, or I did. I had it up here on the board earlier, but.
Can you do 87 as well? I got to the point where I solved it for H.
Did you find the surface area of a circular cylinder somewhere? Man, there was a lot of S's in that. Did you find the surface area of the circular cylinder somewhere?
Isn't it
Sarah?
R squared pi H?
2 pi RH. No, you're thinking about the volume.
Oh.
I'm talking about the surface area, right?
Oh, well then I don't know.
Okay. So let me help out a little bit. Number 87, little clue. Some of these, I'll have to look. I don't remember if they give you the formulas in the section, but you guys, nowadays, you guys have this crazy little thing called Google. Volume of a cylinder. That was a beautiful picture, Jeff. volume of a cylinder is pi r squared. That's the area of the base times the height. That's the volume.
Yeah.
Real quick, can you guys all envision a soup can? You guys have all seen soup cans.
Yeah.
Yes? And you remember, I don't know if you guys ever pulled the label off of a soup can.
Uh-huh.
If I cut the soup can label and then open it up, what shape does it make?
Rectangle.
Rectangle.
Yeah.
Okay, now watch. This is kind of cool. I'm just going to do real quick because we don't have any time for this. Slice, open. So do you see how this is 2 pi r? Is that cool? The circumference around is 2 pi r? Remember that? Circumference of a circle is 2 pi r.
Yeah.
If I open it up then, that's going to be the top, isn't it?
Uh-huh.
And then what's this? That's the height.
Yeah.
Sorry, you guys can't even see it. I love it. So what's the surface area going to be then? 2 pi r times h. So the surface area of a cylinder is 2 pi r h.
Then you gotta add the area of the bottom.
Yeah, then you might have to wonder, and I think this problem said open top.
Yeah.
So then you also have the area of the bottom, which is of course pi r squared. I think this said open top. No top, yeah. So that's the total surface area.
And it would be, so then it would end up being 2 pi r h plus pi r squared.
Yep.
There's a lot of r's in here. Why did math have to add the alphabet? I don't get that.
Because otherwise we'd have blank spaces everywhere. They're just placeholders. All the letters are in mathematics, all they are is placeholders for numbers we don't know. If I did not use it, I wouldn't have anything I could actually work with. Yeah, okay. Sarah, I'm not sure how serious that question was. Yes?
That particular problem said let the radius equal x.
Oh, sure. Then you just put an X there. I love it.
Instead of r?
Yeah, so you can have, yeah,
Okay.
that's fine. Yeah.
If there's too many r's, there's an x.
Okay. All right, so let's do this. Any other dire questions from homework? Okay. We've been talking about exponentials for a while. You all know the shape of an exponential, right? If I ask you to make the shape in the air, can you do it? What's an exponential look like?
The
Okay, all right.
check mark.
That was done with the appropriate amount of enthusiasm. I like that. Yeah. All right. I don't blame you. I'm not saying you should have been all like, yes. So, any function we have to know what the inverse of it is. Why? If I didn't know what the inverse of addition was, could I ever solve x plus 2 equals 6? If I didn't know what the inverse of addition was, could I solve this? No. So we've already discussed the fact that anytime we solve an equation, we're actually applying a bunch of inverses. We're always doing the opposite function, correct? So we have talked about this guy. We now have to talk about its inverse. And let's do a specific example. Let's do 3 to the x again. I think we did that one last time. Can somebody remind me what points I could use to graph this real quick? What are some good anchor points for this? Do it again, sorry. 4, 4?
1, -1.
0, -1.
Yeah, so at 0, 3 to the 0 is what? 3 to the 0 power is?
1,
1. Okay. What's 3 to the first power?
3,
3. And what's 3 to the negative 1 power?
1.
1/3. I like it. So those are my base points. If I wanted to do a transformation like we did yesterday, I would just start with those, do the little dotted line, and go for it, right? So this one I'm not gonna do that, so we're just gonna draw the line. Wee-haw. So I want to make sure you understand a couple things. Where's the only asymptote in this picture?
the x-axis.
0.
Yeah, 0, the x-axis. So y equals 0, which is another name for the x-axis. I love it. Do you notice how on this side it doesn't care about that? So you could have horizontal asymptotes that are only true on one side. What does this do? Is there any x I'm not allowed to use? Is there any x I'm not allowed to raise 3 to? No. So this does go forever. The domain is negative infinity to infinity. Right? I could plug in any damn number I want to. It just rises so fast that if I want to know where it is at 7, it's going to be way the shit up there, right? So this is not asymptotic. It's just rising really quickly. Okay. No idea why I do it. What's the range of this? What does range mean again?
That's the y.
It's all the possible outputs. So
So
what kind of number does this definitely not output?
to negative
Can't have a negative output. I also can't have a
0.
0. So what's the range then? It's everything else. So what's the range from?
So it would be
Y is greater.
I'll tell you this, there's no bracket.
Negative
Parentheses.
parentheses.
Is there anything down here? Are there any outputs down here?
Parentheses.
Any
0
outputs down
to
here?
infinity?
No.
Nope. How do I know? Because that's an asymptote. It's going to keep going and never get there, right? So it can't even get through. Correct?
So would it be parentheses 0,
Good.
comma, infinity?
Yes. Okay. So it goes from just above 0 and up forever, right? You can see that from the graph. No negatives, no zero, so this is everything else. Okay, I like it. Kick ass. Can you guys, has everybody drawn this?
Yes.
What's really neat to me is some of you guys don't have paper or a pencil out, which is really neat. You must have photographic memory. I am jealous. If you've drawn this picture, can you please on the same graph draw the inverse function? So we're going to draw the inverse function before we even know what the hell it is. You guys remember how to draw inverse functions, right? We'll see. So I'll just do this for you. So the original function goes through 1, 3, 0, 1, negative 1, 1/3. So you should be able to figure out what the inverse function does, right? How do you solve? If I give you a function, how do you solve for the inverse function? What do you have to do?
Like undo it.
Switch the x and y, correct?
Oh, yeah.
Switch the x and y. And that is just true. Any damn thing we do with inverses, to find them visually, mathematically, we switch the x and y. So can somebody tell me what points does the inverse function go through?
3 and 1, 0, 3 and 1, 1 and 0,
Yeah, it goes through 3, 1, 1, 0, 1/3, negative 1. Also, real quick, do you guys remember what line it flips over? An inverse function, what line does it flip over? Nope. Nope. Y equals x. It flips over the y equals x line. Remember that? We had those pictures now with some Nazca lines and stuff. Flips over. Do you guys remember? And that should kind of make a little bit of sense. Since we switch x and y, visually it's going to flip over the y equals x line. So tell me, where's the asymptote to begin with? Y equals 0, right? Switch the x and y. Where should the asymptote be now?
X equals 0.
X equals 0. So now this is going to be the asymptote. You see it just flipped over the y equals x line. And you can even see that as you're plotting points. So what does my inverse go through? 3, 1, 1, 0, 1/3, negative 1. So you can already see it going like that. It's going to start approaching this. So here's what this looks like. You remember your inverse? We did a few inverse graphs. You remember? You can see that the line right down the middle, y equals x, that's the mirror, correct? You guys see that? So what we just did together, we just graphed the inverse function before we even know what the hell it is, correct? Okay. Yes?
What do you mean before we know what it is? Like if we know all the values.
Like here, I know this function, correct? I can write down that function. We don't currently have a name for this function. You guys might know, some of you guys might know where we're headed. Okay. Again, all right. So this is the function that just undoes this one. It takes all the values that this guy outputs and brings it back to what was the input, right? That's what it does. We have to give it a name. So help me out. You guys know when I write this problem, cube root of 8, you have internalized what that means. What is it asking you? The symbol that we picked. Sometime in history, that symbol was chosen. Aliens didn't come down and say, you will use this or we will vaporize you. That did not happen. We got to choose the symbol. And to be honest, that's an okay symbol. I could live with that symbol. Could have been a lot worse. Can anybody tell me? Well, tell me the answer. Why? What is the symbol asking for?
Cut 8 in...
Cut 8 in thirds, I love it. Or even, what does it take 3 of to multiply to be 8? Does that make sense? You guys with me? Mm-hmm. You've internalized the meaning of this so much, you don't even have to bring up the English. It's sort of like if anybody ever starts learning a different language, you can't just speak it. You have to think English and then translate it. You got to do that, right? We've gotten so good with this particular symbol in Mathish that you don't even stop to necessarily think about the sentence it means, right? So this symbol represents a sentence. What does it take 3 of to multiply to be 8? That's why we do what we do. Are you guys with me? And you're all like, dude, you're talking about cube roots. Come on. All right. So like, if I had this, what would that mean? What does it take 5 of to multiply to 32, right? And then you have a way to kind of solve it is to start, if you break this up, 4 times 8, 2 times 2, 2 times 2 times 2. Do you see the answer? What's the answer? 2. It takes 5 2's multiplied by 32. So if you know the symbol you're given, if you understand what it's replacing, what sentence it's replacing, what question it's replacing, you know how to attack the problem. Because we're about to look at one of the weirdest symbol choices in all of mathematics, which I think is what turns students off. You see the symbol and you're like, what the shit? It's just a bad choice, in my opinion, of symbol. We're just going to have to deal with it. Okay. So in much the same way, now watch this. So if I was to say 2 to the what equals 8, do you see how that's the exact same question as this? It's just that I have to use an empty space. So that's why we developed the cube root symbol, so I can represent this question more directly. I want to do something to 8. I don't want to say 2 to the what equals 8. You guys sort of, or actually, I've done that backwards. I love it. What to the third power equals 8? That's the better question. Okay. What to the third power equals 8? That's what that's asking. You with me? I like it. So we want to stay away from this. We want to be able to do something to 8 directly, not have this indirect question. Okay. So coming back to this. The symbol that we chose. So for example, right here, this would be 3 to the what equals, you could do it, Jeff. 3 to the what equals, oh, don't overthink it, Jeff. So if I said 3 to the what equals 3, let's start there. 3 to the what equals 3? What's the answer? 1. So that's pretty simple, right? If I said 3 to the what equals 1/3, -1, right? But again, we need to develop a symbol to capture this idea. So I'm not always writing this freaking little parenthesis with an empty space. I want to be able to have a symbol that means this question. So the symbol we chose to represent 3 to what power is this symbol.
Does that say log?
It totally
Yes.
does.
I know.
All right, everybody, deep breath in. Deep breath out. Okay. Now go with me. So, let me ask you this. Okay. So now we know the shape of a logarithm. That's the graph of log base 3. That's what it looks like. So logs are just inverses of exponential, so it kind of makes sense they're going to look like that, which is the inverse of an exponential. Okay, so the shape of it makes sense. Like I said, do you guys all understand that this root symbol, one reason that's so nice is because you grew up with it. If all of a sudden we had to use metric system, would that make you feel great?
No.
Can anybody show me how big a decimeter is? Yeah, so it's like 10 centimeters. I like it. Yes?
Why couldn't you just do the square root sign, but instead of like where the cube would be an X?
Because again, I every simplification problem I have that I ask does not have an X in it necessarily, right? I can ask you to simplify 2 plus the absolute value of -3 minus the cube root of 27, correct? Nowhere in there is there an X.
But you know it's cube root because of the 3, so
Beautiful.
that's what you were asking to like figure out what it's rooting by. You just put X.
I see what you're saying. Okay. So it's not asking, how do I want to say this? Again, I want to be able to, is there any X in any of this? No, even though this is a backwards thing, isn't it? Isn't this a backwards question? What does it take 3 of to make 27, correct? So I want to be able to write, if the question is 3 to the what equals 27, I need to be able to write that in a way that 27 is the input. Because when I do this inverse, aren't the inputs the outputs of this guy? Okay. So if I see this question, log base 3 of 27, if we just internalize the question that symbol means. So what's really nice about roots is we all have used roots a lot. You guys don't even realize that you're translating because you do it so automatically, you don't even see what you're doing. That's like in English. I don't have to stop and think about the word tree. I don't have to think what a tree looks like. I can just say the word tree, right? Without really thinking. But if I'm learning German, I've got to go, tree is this, and then I say it, right? When I'm first learning a different language. Yes?
So would the answer just be 3?
Totally. All this is asking you is what power does 3 need to make 27? Or how many of these multiply to be this? They both mean the same thing, right?
So what is log like actually like? Is it just like for inverses or?
So you all agree that x cubed, the inverse is cube root of x. Does everybody agree with that?
Yeah.
Anytime I have a function that has a symbol, if it has an inverse, I want to give that a symbol also. Can you imagine if I wanted to say 8 minus 2, but I had to say 2 plus what equals 8? I had to write all that shit just to say 8 minus 2? Do you understand what I'm saying?
Yeah.
So that's why we came up with a symbol that represents this idea. You guys with me?
So it's to basically just help you figure out the inverse.
It gives us a way to directly do something to a number. So instead of saying to somebody, what cubed is 8, I say the cube root of 8. Because we developed this symbol. What does that symbol mean? It means this. That is the question you ask yourself, correct? Okay, now watch, guys. Whenever you have a log question, stay with me. One thing is, how do you read this? You read this as log base 3 of 27. Oops. The base is 3, and the answer is 27. So then you ask yourself, whenever you see a log question, you say, what power does this need to become this? Or, how many of these multiply to be this? So what power does 3 need to become 27? 3. All right. Don't say anything. I'm going to write another problem. Do not say anything. Don't say anything. All right. Think about it. What question is that asking? There's a few different ways you can word the question. What question is that asking?
What squared equals 16?
No.
How many 2's do you need to make 16?
Yes. So how many 2's multiplied by 16? Or what power does 2 need to become 16? Those are both the same. Are you guys with me? Because powers just mean repeated multiplication, correct? So you can ask the question to yourself either way. And you're going to have to do that because it's just like learning frickin' German. When you first learn vocab, you're going to have to think and then translate. It's not going to be automatic. Thank the gods I don't have to do that with English, or else I'd be up here like this, right? I have to think about each word and then shoot it out of my mouth. All right, you guys with me? This is brand new words for us. And it is actually a little word. I know there's a lot of dumb jokes about log cabins and shit. Yes?
So, the 2 is
The base.
what we call the base, right?
Yeah, it is the
What's
base.
the other base?
What do you
Or
mean?
what's the other number called?
This would actually just be the output. So
Okay,
this represents this question.
yeah.
Okay.
So it's 8.
No?
It's 4.
It's 4. Yeah. So it's not division. It's powers. How many 2's multiplied by 16? Or what power does 2 need to become 16? 4. Is that cool? Which means I can always rewrite a log statement like this. 2 to the 4th equals 16. I can check myself.
Oh, yeah.
Check yourself. Okay. Show me what you are working with. Okay. What about this? Log base 3 of 9. Don't say anything. All right, now tell me.
2.
Why?
Because 3 times 3 is 9.
Yeah, good. Either you can say 3 squared is 9, or because 3 times 3, so it takes 2 3's to make 9. They both mean the same thing. Yes,
Do we have to write it a special way, or is just saying equals 2 already?
that is it. This other shit is just me reminding you why 2 is the answer, right? I like it. So you see, roots are different. Roots have a set power. So when I ask you the cube root of 8, the power is 3. I'm asking, what do I raise to the 3rd power to get 8? This is different. The base is set. The power I don't know. So there are some similarities between roots and logs, but they are not the same thing. No way. Yes?
So, can logs be used for like any function? Like to find like any inverse? Or
Oh, no.
just-
Logs
just
are the
exponents?
inverse of exponentials. So what is this the inverse of? 3 to the x.
Okay, so
Yeah.
it's only, okay.
Just like, so the inverse of a cube is a cube root, right? The inverse of plus is minus. So
So this
yeah.
is only used for.
So don't get too excited.
exponentials.
This is an inverse we got specifically from an exponential function. So those go as a pair. Function, inverse function, they only go together. All right, let's try a few more. And then I got a handout so I can finally shut up. You guys are like, good Lord, this guy just talks and talks. Almost like it's my job. So what about log base 9 of 81? Again, what do you ask yourself? Yeah. Why is it 2? Because that's what 9 needs to become 81. 9 squared is 81. Or because it needs 2 9's to multiply by 81. All right, let's try something a little weirder. Log base 9 of 1/9.
Oh. I don't like that.
No, it's not a big deal. Come on. Yeah?
Oh.
Sure.
-1.
-1. What power flips 9 is basically a way to say that. What power does 9 need to become 1/9? Well, what powers flip things? You guys with me?
Okay.
So let me do a succession of things. Let me actually, and then I think I'll give you the handout. So watch this. Let's do log base. Let's do 3. Sure, we've done 3 already. What's log base 3 of? You can do it, Jeff. 9. We did that a second ago, right? What's log base 3 of 3? 1. You guys with me? Do me a favor. If you're copying this in your notes, leave a space here. What's log base 3 of 1?
0?
0. I like it. You guys all with me? Is everybody cool with that? In fact, log base anything of 1 is 0 because that's what I raised something to make it 1. Is that cool? Now what I want you to put here is this. Log base 3 of 1/3. Was it that you wanted, Jeff? No. Let me try again. Log base 3 of square root of 3. All right, this gets a little weird. What is the answer to a log always? Can you guys see? What is that? What is an answer to a log? It's always a power. Kick ass. Let me say this again. This is huge. The answer to a log is a power. So logs are powers. Whenever I ask you a log question, it's fundamentally asking you for a power. What power would be needed?
Is it half?
Yes, good. Kick ass. What do I raise 3 to make it square root of 3? 1/2. 3 to the 1/2 power, right? In fact, watch this. If you just rewrite, how do I rewrite 3? 3 to the 1/2. So this is when it's written like this, it's almost silly. What power does 3 need to become 3 to the 1/2? Well, frickin' 1/2. I can just see that shit, right? So side note. What if I ask you, what's log base m of m to the 7/4? Freaking 7/4. Do you guys see that?
Yes.
Because it's asking me, what power does m need to become m to the 7/4? It told me the answer. Also, remind me, log base 3, what is that the inverse of? 3 to the x, right? So log base 3 of x and 3 to the x are inverses of each other. Everybody with me? That's how we developed it. We made it first, and then we came up with a name for it, right? We didn't come up with it. We just have to deal with what people in the past came up with. What do inverse functions do to each other when you plug one into the other one? You know this. If I plug a cube into a cube root, what do?
Oh, they can't.
Kill each other. We know this shit. We've done this before. They kill each other. So aren't log base m and m to a power, aren't those inverses? Log base m and m to a power are by definition inverses. Log base 3 and 3 to a power are inverses. You guys with me? So log base 4 and log base 4 of x and what are inverses? Log base 3 of x and 3 to the x are inverses. Log base 4 of x and 4 to the x are inverses. Yes?
Yes.
Log base 11 of x is the inverse of 11 to the x. Log base m of x is the inverse of m to the x. So these two are inverses, correct?
Yes.
What do they do to each other?
Cancel.
So the answer is freaking 7/4.
Okay.
Just like a cube root and a cube killing each other, right? So these are things you guys don't even think that these are inverses. You just know they kill each other. But now we have to kind of keep that more in mind because we got this freaky ass new function which is an inverse, and we got to go, oh shit. Now I got to really be thoughtful about what's happening because I'm not used to it. It's sort of like using meters instead of feet. You have to be really thoughtful because we grew up in America, the last country on the face of the earth that doesn't use that. All right, I'll see. Okay, so log base 3 of 9 is 2. Log base 3 of 3 is 1. Log base 3 of 1 is 0. Guys, so watch. You guys with me? Log base 3 of 3 is 1. Log base 3 of 1 is 0. So log base 3 of something between 3 and 1 is going to be between 0 and 1. Do you have to actually know that to do problems? No, it's just interesting. Say again?
I thought anything to the first power is 1.
No.
No, we
Wait,
put
no.
the 0.
I know what
Zero
you're
power.
flipping a few things. You're flipping a few things. Anything to the 0 power is 1. Anything to the first power is itself, right? 7 to the first power is 7.
Yeah.
I've got 1 7, so it's 7, right?
Yeah.
Okay. So
then
3
why
to the
is that-
3 to the first power is 3,
Uh-huh.
right? 3 to the first power is 3. 3 to the 0th power is 1.
Oh, okay.
So you can always draw these little arrows.
Yeah,
Base
okay.
to the answer equals the input. Yeah.
Okay.
Okay. So what's log base 3 of 1/3? Now I want to put that there. If log base 3 of 1 is 0, log base 3 of something less than 1 has to be less than 0. Does that make sense? And of course, we already know this. We already know this.
That would be negative 1.
Yes. What's log base 3 of 9 again? 2. So what's log base 3 of 1/9? Negative 2. Do you guys see that? What's log base 3 of 27? How many 3's to multiply to be 27? 3. So what's log base 3 of 1/27? Freaking negative 3. Do you guys see that?
Yeah.
There's a beautiful symmetry there. If it's 1/, just take the 1 away for a second and then put a negative on your answer, right? Okay. So let me give you this. I'm going to finally, I've been carrying these around for a while. Okay. So excited. So listen, there's a lot of writing at the top, which is for you later if you want to kind of review the idea of this. So there's a lot of writing at the top here. And I even tell you where the name comes from, as if you need to know, but just in case you're curious. I want you to focus on doing these problems down here, right?
Okay.
Obviously, you can read stuff.
Practice or is it due?
This is practice, yeah. Make it a quiz. No, I'm joking. Pop quiz. I don't do this. Anytime. So try these out down here. If you want to work with other people, you either completely get it or you completely don't. And if you completely don't, do not feel bad. This shit is weird. You've never seen a symbol like square root be a little frickin' word, correct? We are going to learn more of that when we get to trig, which is really, really close in our future. It's the next chapter. So you're going to learn stuff like tan of 30 degrees, tangent of 30 degrees. And we're going to see a lot of little tiny words. There's going to be sin and cos and tang and all this kind of weird shit. So this is our first little foray. Now, real quick, again, I don't know if you guys really understand when I say this kind of stuff, but and you're like, I don't understand any word coming out of your mouth. This symbol didn't have to look this way, correct? We could have chosen it. We could have chosen it to be this or something weird. Let's put the 3 and the 8 like it's in the belly, little baby. No, that makes sense. So, the symbols we chose didn't have to be the way they are. Personally, I think this is one of the worst choices in all of mathematical history. But then it's okay. All right, so what? It's sort of like, do you guys know what Finnish looks like? My mom is Finnish, and I try to learn some Finnish. And the joke is, it seems like every other word, they try to put all the letters into that word. I was like, oh my God. Oh. Anyway, so I know how to speak a little tiny bit of Finnish. Not very much. So, we get over the fact that it's a word, and we get over the fact that it's actually a word that makes sense, log. We know what logs are. And we just say to ourselves, what is the question, right? So it's just like when you first learn a language, you're going to go a little slower because you have to translate for yourself as you go. What question is this asking us? 2 ways you could put it.
How to cut 81 into thirds?
What? 3 to the what power do you think?
Not quite. You're not cutting 81 to thirds.
What times what? 3 times
power is 3?
You're actually asking how many times you have to cut 81 to make the answer 3, which is weird. So you can either say, how many 3's, 3 to what power makes 81, or how many 3's multiply to be 81, correct? And if you don't immediately know, you could just start factoring 81. See what the shit goes into it. Isn't that 9 times 9? And isn't each 9 3 times 3? So now you know the answer. How many 3's multiply to 81? 4. Or what power does 3 need to become 81? Those are the exact same question because powers mean repeated multiplication. Is that cool? So everybody who groaned about logs earlier, is this a little better Okay.
Sort of.
So it's all a matter. I don't think a while back I realized it's all about translation. It's all about what does that symbol mean? And you're so used to every symbol you see, you sort of already know what it means. And this is sort of the first symbol that it's like, holy shit, what is that? You're not used to translating because you know what a square root means. You don't even really realize you're translating because it's just automatic. You know what it is. So here, again, what is this asking you?
What to the power of 4 equals?
No, careful. 4 to the power of what?
What power?
4 to the power of what makes 16, or how many 4s multiply to 16? Of course, that's the nice one, 2. And again, just to remind you, you can always do this. 3 to the 4th power is 81, check. 4 to the 2nd power is 16, check, right? You can always check it at the end. This one should be easy. Log base almost anything of 1 is 0, because anything to the 0 power is 1.
1.
Did I turn you back on? Yes. This guy looks almost the same as him. Yeah, we already did this problem. That was easy. 4 2s multiplied by 16, right? Okay. Careful. Hold on. Let me get there. So this one is, your brain won't accept that it's as easy as it is. So real quick. The problem we just did, log base 2 of 16. Yes? Let me do something you never would really have to do, but just to make a point. Isn't 16 2 to the 4th power? If the inside is written with the same base and a power, it's telling me the answer, because the question is, what do I raise this to make this? Well, it's telling me raise it to the 4th power, dude. You can also look at it as these cancel. Why do those cancel? They're inverses, right? So you can look at it one of two ways. You could just say b to the what power is b to the 8th. Well, I just said the answer. Or these things cancel and 8 is left, correct? Okay, I like it. We've done one like this already. -1, because 5 to the -1 equals 1/5. This one we already did. -2. 3 squared is 9, so 3 to the -2 is 1/9, right? Negative power just means flip, that's all it means. What about this guy?
1 over m.
It would be
Nope.
2/3.
Yeah, how do we rewrite this? Remember, roots like plants are on the bottom, powers are powerful on the top. So how do I rewrite this? It would be
M to the
2/3. And then it's a problem just like E. Either these cancel, or you just go, I raise it to the 2/3 to make it m to the 2/3, right? Logarithms. Not that bad. Okay. Who has their calculator with them? I didn't bring them with me, and I really should have, but do you guys see on your calculator? Let me remind myself what it looks like.
log.
Yeah, you see the log? Right there?
Oh, yeah.
What's above it?
X squared.
10 to the x, right? So let me talk really quickly about this. So help me out. If I have 10 to the x, based on what we talked about earlier, what would the inverse be? You could do this. Log base 10 of x.
X.
You with me? That's the only time I'm ever going to write a 10 there. Sort of like, you guys know what that symbol means, yes? What's that symbol mean?
That's square root.
We don't need a 2 here to tell us that, do we? Because we know, and why did mathematicians decide not to write the 2 there? Because it's the most commonly used root. So we just said the one that have a number is the one we always use the most, right? What is our number system based on? What number is our number system based on? 10. I have no idea why that might be true. And we live in California. What happens in California that doesn't happen like in my old state of Virginia? What happens here sometimes? Natural event. Earthquakes. Do you guys know Richter scale? Do you guys know what that's built off of? That's built off of log base 10. That's built off of log base 10. So if I say a magnitude 4 earthquake versus a magnitude 5 earthquake, the magnitude 5 earthquake is 10 times more powerful. It's a logarithmic scale we decided to use for Richter scale. Again, you don't have to memorize this. I'm just trying to show you a few places we use logarithms. You guys ever heard of decibels? Like, there's always this thing about a concert versus a jackhammer, right? And the level of noise. You measure the level of noise in decibels. Have you guys, anybody ever heard it? I know a few of you guys. That also is a log base 10 idea. Okay, all that's on the side. So I am never going to write this. This hurt me just a little tiny bit to write. And I'm really not joking. So you're always going to see me write this. This is what's known as the common log. Nothing to do with the wrapper. Common log. As far as I know, it has nothing to do with the wrapper. So if I ask you, what is log of 100? Nope. Sorry? I did. I totally did. I totally gave you a base. What did I just say? When there's, just like when I write a square root symbol, do you guys go, wait, you didn't give me a root? Well, of course I did. When it's not there, it's 2. When it's not there on the log, it's 10. So what's log base? Let's log of 100? 2. 10 to the 10th is crazy big. So logs are all about powers. Logs are not division. 100 divided by 10 is 10. 10 to the what power is 100? 2. I like it. So real quick, what's log of 1,000? Do you guys notice a pattern? How many zeros do you see? Yeah. So if I see a Richter scale 2 earthquake, Richter scale 3 earthquake, the Richter scale 3 earthquake is actually 10 times as big in power. Do you guys see that? Okay. That's why we decided to use Richter scale, the log base 10, so we can use 2, 3, 4 instead of 100, 1,000, 10,000. We just made it so that we can talk about smaller numbers to represent the strength. Oh, good. I got time. You guys are so, like, come on, clock. All right. Maybe you're not. I should stop assuming. All right. So what are some of the things we could do with logarithms? One of the main things we could do, we're not going to be able to do quite yet. Eventually, so let me ask you this. You guys can solve this equation. How do you solve this equation? This is easy, right? Solve that equation for me. You actually don't have to do anything, correct? You just have to think about what's the answer going to be, correct? All right, what about this equation? Can you tell me the exact answer to that equation? Not so easy, right? Remind me, how do you solve this equation? What would you do to both sides?
Power 5.
Why would you use the fifth power?
So you can cancel.
Because that's the inverse of this, correct?
Yeah.
So would you?
So if
use
I want to
log?
solve this, we would use,
log?
yeah. So
I
let's,
remember this.
we would use, yeah, so watch this. Let's use one that's actually in our calculator. What if I want to solve this equation? Real quick, we will eventually get here, but we're not quite there yet. We can do this one, though, because the log button's on our calculator, correct?
Yeah.
If I want to solve this equation, let me see. Make something up, Jeff. There, look at that. There you go. I can estimate this. 10 squared is 100, so my estimate would be like 2.1 or something. It's just a little more than 2. Does that make sense? Because it's a little more than 100. So watch this. The same way you guys told me to take the fifth power both sides here to kill the fifth root, because they're inverses. What's the inverse of 10 to a power? Log. I like the way you say that, because it's just log. Everyone knows it's log. If I take the log of both sides, do you guys see that? Same way we took the fifth power of both sides, I'm going to take the log of both sides. So what happens on this side? We constructed this to die. So the x equals, now can you guys real quick, anybody has their calculator, can you do that in your calculator? What is log of 114?
2.
Yeah, 2.06, if I want to round up a little bit, roughly. Which is about what I predicted, and I think you guys would agree with me. 10 squared is 100, so 10 to the little more than 2 would come out a little more than 100. Does that make sense? This is an immediate reason we want an inverse symbol so I can apply it to equations that I need the inverse, right? If I didn't have an inverse symbol, how the hell would I kind of directly solve this equation?
Wait, that's the symbol.
Log is the symbol of the inverse. So if I apply log to both sides, it accomplishes the same thing as raising both sides to a fifth power did up here. Yeah.
So when let me collect my words.
I understand.
On tests and just like homework problems in general, would you want us to round up, or can we just take?
I'll say, for a problem like this, I would say round your answer to the nearest hundredth or something.
Okay.
So this is rounded to the nearest hundredths, right?
Okay.
By the way, real quick, I'm glad you asked that question. Which one of these is the exact answer? The first one or the second one?
The first one.
Do you understand? Now think about it. It definitely cannot be the second one, can it? Because didn't I round this?
Yeah.
This is the exact answer. Did I round this? Didn't round it at all, right? Now some of you guys might go, that's not an answer, Jeff. But couldn't this be an answer to a problem? And that's the exact answer. If you put a decimal, isn't that going to be approximate? So this is the exact answer. This is the approximate answer. Be really careful. I can't remember if in the homework it does that, but on a test or something, I'm going to say, give me the exact answer and an approximate answer. And that's what I mean. Is that all right?
Mm-hmm.
Sort of like square root of 2 is the exact answer. 1.414 is the approximate answer. Okay, same idea. Okay, I like it. So one little teaser for where we're going next with these logarithms. There are properties of logarithms. And I just really, right now, I want to lay down some groundwork of things. Remind me, what are logs again? What are they fundamentally? What are they? Why do they come out the way they do? Because, say again?
Inverses of the
Kick ass. But one word. Logarithms are
Powers.
powers. Right? This makes sense because anytime I see a log question, I'm thinking about what power do I need? The answer is the power the base needs, correct? Properties of logs are going to be the exact same properties of powers because logs are freaking powers. So we got to remember our power properties, right? So for example, when I multiply two like bases, what do I do with the powers? You add them. Is that cool?
Mm-hmm.
And I like to freak people out. I like to make people think maybe I didn't take all my meds or something. I don't see any 2 or 3 in here anywhere. I don't see a 2 or a 3. So how could the answer be 6, right? Now some of you guys are like, you wrote the damn thing, Jeff. What does that symbol actually mean?
Squared.
No. It does mean square, yes, but it
Tells you
means
how
there's
many
2 x's. I love it. So there's 2 x's in a row times 3 more x's in a row. So of course there's 5 x's in a row, right? Okay. What if I raise a power to a power?
Then you multiply it.
Then you do, because that's 3 groups of 2 x's. That's like elementary school definition of multiplication, correct? 3 crates with 2 apples in each crate. 6 apples, right? 3 groups of 2 x's, 6 x's. Kick ass. What about if I divide?
Then you subtract.
Subtract. Why do I subtract? Because if I do this, and
Because you're taking the
you would
whole
never
thing.
do this, right? Don't ever do this. But if I did it, how many x's cancel? Didn't I just lose 3 x's, right? So a shortcut, it's just a shortcut. So I don't ever have to do this. A shortcut is just 5 minus 3 because I'm going to lose 3 x's. I'm going to have 3 x's cancel. You guys with me so far? Okay. I love it. So, for example, how much can I sneak in here? If I have log of a plus b. Well, no, let's not do that, Jeff. Sorry, erase that. Log of a times b. There it is. And let me put a number in. Let's just put 7, just because. Both a and b they have a base of 7. Do you guys agree with me?
Mm-hmm.
Yes.
Okay, so let me try to do this. I'm going to try. This is the last thing we'll do today. Yes. Okay. I'm going to try to do this. Okay. So those are kind of like the pieces of this in a way. Do you guys see that? Yes.
Why wouldn't it be? What? Aren't you multiplying A and B together?
Totally.
So wouldn't it? So would the A and B stay together?
We'll see. I'm going to prove something. Go with me for a minute. In fact, I don't know if, well, okay. This is going to get a little weird. So anytime I'm trying to prove something, it's going to get a little abstract. I don't know what log base 7 of A is. Does anybody here know what that is? I don't have a freaking clue. So let's call it X because we're, basically in algebra. What's log base 7 of B?
Why?
Y. Can't call it X also, right? So we'll call it Y. So therefore, let's see if you guys are cool with this. What is A?
7 to the X.
Kick ass. You guys see that? 7 to the X equals A. And what's B?
So 7 to the
7 to the
Y.
Y. Kick ass. So what is A times B? There it is, Sarah. I brought it back.
To the X times Y.
7 to the X times 7 to the Y,
times
right?
7 to the Y.
What do you do with the powers?
Get out of it.
7 to the XY?
You add the powers, correct?
Oh, yeah.
Is everybody with me?
Okay.
We know this.
Yeah.
When I have like bases. By the way, I want you to understand, everything I'm doing right now, you're never going to have to do. This is a derivation of a shortcut,
okay.
right? This is what I meant earlier about we're about to get abstract and all that stuff. Stay with me now. The original question was this, correct? So let's see. Log base 7 of AB. What did we just figure out AB is? 7 to the X plus Y. So that's log base 7 of,
X plus Y.
well, I'm sorry. This will be X plus Y. These cancel. Is that cool? We stop for a minute. If you're all cool with what happened up here, I just replaced AB with what it is. Log base 7 of 7 to a power is easy because they just cancel, so I get X plus Y. What was X?
A.
No, log base 7 of A. What was Y?
Log base 7 of B.
So look what this says. This says if I have the log of a product, it's equal to the sum of the logs. Why does this make sense? Do you guys agree with me? What's the base in this statement? What's the base? 7. So these both have 7 as a base, correct?
Uh-huh.
When I multiply two things with the same base, what do I do with the powers?
Get out of it.
Add them. Aren't each of these powers, because logs are powers? When I multiply things with the same base, I add the powers. That's our first little property of logs. Obviously, next time we'll do some examples and talk about the other properties. That's enough for today. But basic logarithms, let them be nice. You know how to attack them because you know what the log means. Okay.